Welcome to Tutorial 4. The next part of the climate system that we'll explore is the ocean climate system and the different processes that affect climate. One ocean climate system process are the surface ocean currents. Surface currents in the upper 100 meters of the ocean are driven by wind associated with atmospheric processes, such as the trade winds and Hadley circulation that we discussed in the previous tutorial. These currents transport heat and nutrients within the surface ocean. However, there are also currents that occur at deeper parts of the ocean. In this map on the right, the red arrows are warm surface ocean currents, and the blue arrows are cooler deep ocean currents. These deep ocean currents are driven by differences in the water's density, which is controlled by temperature and salinity. Most of these deep water currents form in the polar regions on Earth, and this is related to changes in temperature and salinity in these regions. In Earth's polar regions, the surface ocean water gets very cold and forms sea ice. As you can see in the maps on the left, the upper left map is showing changes in sea surface temperature with latitude, and the polar regions are much colder than the equatorial regions. In addition, the bottom map is showing seawater density, and you'll notice that there's a similar pattern to temperature, where the tropics have less dense waters and the poles have denser waters. When sea ice forms in the cold polar regions, the surrounding seawater gets saltier because the sea ice preferentially takes the fresh water, so the salt gets left behind. As the seawater gets saltier, its density increases and it starts to sink. And this is what initiates those deep ocean currents and what drives this large-scale global ocean circulation pattern. We can take a closer look at two examples of regions in which surface water downwells to deeper parts of the ocean and regions where deep water upwells to the surface. Two areas of deep water formation are in the North Atlantic and Antarctica, and this deep water forms via the density-driven processes that we discussed in the previous slide. In contrast, there are some parts of the ocean where deep water makes its way back to the surface. These are known as upwelling zones. Surface winds move warm surface water away, and deep water gets upwelled in its place. This deep upwelled water is cold and nutrient-rich, and this process of upwelling commonly occurs on the west coast of continents. For example, the west coast of South America is a big upwelling zone. Similar to the atmospheric processes discussed in the previous tutorials, these ocean circulation patterns also serve as a mechanism of heat transport. In this tutorial, we'll explore monthly global sea surface temperature data from the Community Earth System Model 2. We'll create a map of sea surface temperature, and we'll use various arithmetic and aggregation methods in X-ray to help us interpret the data.